There is a force field protecting our planet, an invisible shield generated by an ocean of superheated iron swirling 3,000 kilometers beneath our feet. It deflects a constant barrage of cosmic radiation and solar winds that would otherwise scorch our atmosphere and make the surface of Earth a barren, radioactive wasteland. We rarely think about it. We call it Earth's magnetic field, and it has been protecting life for billions of years. But right now, it is failing. In 2017, something strange began happening to the European Space Agency's swarm satellites. As they passed over a specific stretch of the South Atlantic, their systems would glitch. Alarms triggered, computers rebooted. It wasn't a software bug or a solar flare. It was something far more profound. The Earth itself was failing them. This region, now known as the South Atlantic Anomaly, is a massive and growing weak spot in Earth's magnetic field, our planet's only defense against lethal cosmic radiation. Here, the field is so thin that charged particles from the sun can dive dozens of miles deeper into the atmosphere than anywhere else. It's a crack in our armor, and it's getting bigger by 5% every year. But the story doesn't start with satellites. It starts with clay. For decades, archaeologists studying ancient pottery noticed something peculiar. When clay is fired in a kiln, its iron-rich minerals act like tiny compass needles, locking in the strength and direction of Earth's magnetic field at that exact moment. By analyzing artifacts from Babylonian jars to Roman vases, they pieced together a startling history. Earth's magnetic field has weakened by nearly 15% since the 19th century. The decline isn't gradual, it's accelerating. This double revelation, from the relics of dead empires and the silence of orbiting machines, points to one terrifying conclusion. Our magnetic field, the silent guardian that has allowed life to flourish for eons, is collapsing. And this collapse may be the opening act of a planetary-scale event that has occurred hundreds of times before, a full magnetic pole reversal, a process where the north and south magnetic poles swap places. This has happened hundreds of times in Earth's history, and it will happen again. To understand why our magnetic shield is failing, we must take a journey to the center of the Earth. Not with a drill, but with science. Past the crust we walk on, past the solid mantle, we arrive at a place of unimaginable violence, the outer core. Here, under pressures 1,000,000 times greater than our atmosphere, and temperatures rivaling the surface of the sun, lies an ocean, but not of water. This is a 2,200-kilometer deep sea of liquid iron and nickel, constantly churning. This furious metallic ocean is the source of our magnetic field. Scientists call it the geodynamo. Think of it like a bicycle dynamo, but on a planetary scale. As the Earth rotates, it spins this molten metal ocean. This movement, combined with the heat rising from the even hotter inner core, generates enormous electrical currents. And as any physicist will tell you, moving electrical currents create a magnetic field. This self-sustaining feedback loop is our planet's life support system. It has been running non-stop for over 3 billion years. But this engine is not smooth. It is inherently chaotic. Convection currents within the liquid iron behave like a weather system, with turbulent storms and complex flows. Computer simulations show that when these flows become disorganized, the entire system can become unstable. The dominant two-pole magnetic field, the simple bar magnet we all learn about in school, begins to break down. Smaller, competing magnetic poles emerge all over the core, fighting for dominance. Imagine a bar magnet breaking into a dozen smaller magnets, all pushing and pulling against each other. The unified, strong dipole field collapses into a chaotic, weak multipole field. This is the beginning of the end for the magnetic field as we know it. This is the start of a reversal. The process isn't quick. It's a planetary-scale seizure that can last for millennia. The magnetic poles don't just neatly flip, they wander erratically. The North Magnetic Pole might shoot over toward Siberia, then drift down past Europe, while a temporary South Pole emerges off the coast of Africa. The field's strength doesn't drop to zero, but it can diminish to a mere 10% of its current strength. For thousands of years, Earth's shield would be a tattered, porous net. The weakening we see today, the South Atlantic Anomaly, is the smoke. The geodynamo's growing instability is the fire, and we are just now beginning to smell it. Our guardian doesn't stand still. It is a living, breathing, and deeply unstable force, and it is currently losing its mind. So what does a world with a crippled magnetic field actually look like? The Hollywood version involves apocalyptic earthquakes and instant extinction. The reality is more insidious, and in some ways, more dangerous. Let's start with the most immediate threat, our power grid. High-voltage transmission lines stretching for thousands of miles act like giant antennas. During a geomagnetic storm, even a minor one, solar particles can induce powerful electrical currents in these lines, overloading transformers and causing catastrophic failure. In 1989, a much smaller storm left 6 million people in Quebec without power for 9 hours. During a reversal, with our magnetic field at 10% strength, a storm of the same size would be catastrophic. We're not talking about a blackout. We're talking about a grid-down scenario, continent-scale destruction of critical infrastructure that could take months or even years to repair. Society would be forced into a pre-industrial age overnight. Our eyes in the sky would be next. Satellites, which we depend on for GPS, global communications, weather forecasting, and financial transactions, would be operating in a shooting gallery. Without a strong magnetic field to deflect them, solar and cosmic radiation would degrade solar panels, fry delicate computer systems, and dramatically shorten orbital lifetimes. Low Earth orbit could become a graveyard of dead technology. We would be forced to become a low orbit, if not a purely terrestrial civilization. For life on the surface, the threat is more silent, but no less dire. The increased radiation would mean a higher background dose for every person on the planet. This wouldn't cause immediate sickness, but over a lifetime, it would significantly elevate the risk of cancer and genetic mutations. It would be a public health crisis unfolding in slow motion, a statistical shadow hanging over generations. The natural world would be equally affected. Creatures that navigate by magnetoreception, birds, sea turtles, whales, even bees would become disoriented. Migration routes that have existed for millennia would break down, threatening ecosystems and food security. And then, there would be the sky itself, the aurora borealis and australis. The beautiful northern and southern lights are created when solar particles are funneled safely toward the poles by our magnetic field. In a weakened multipolar field, this funnel breaks down. The aurora would no longer be a rare polar spectacle. It would become a global phenomenon. You might see shimmering curtains of light over Paris, Tokyo, or Buenos Aires. It would be one of the most beautiful sights in human history, and a constant grim reminder that the protective bubble we once lived in is gone. This is the paradox of the reversal. It is not an instant doomsday. It is a slow-rolling emergency, a crisis of resilience. It would not break our planet, but it would brutally test our civilization. It challenges our infrastructure, our health, and our place in the natural order. The question is no longer if the field will flip, but whether we will be smart enough and resilient enough to flip with it. To predict our future, we must first learn to read the past. But this is no ordinary history book. Its pages are made of stone, its ink is magnetic, and it is buried deep within the earth itself. This is the detective story of paleomagnetism, the science of reading the planet's memory, and it reveals a shocking truth. Our stable, reliable magnetic field is a chaotic shapeshifter with a history of spectacular identity crises. The evidence is literally set in stone. When volcanic rock cools, or when sediments settle on the seafloor, tiny magnetic minerals within them, like minute compass needles, freeze in place, aligning themselves perfectly with the Earth's magnetic field at that exact moment in time. They become fossilized echoes of the planet's magnetic heart. It is our most reliable time machine. And what does this time machine show us? It reveals that the magnetic field is not a constant, humming guardian. It is a dynamic, seething entity that breathes, wobbles, and, every few 100,000 years, completely loses its mind. It flips. North becomes south. South becomes north. The last full reversal, known as the Brunnes-Matuyama reversal, happened 780,000 years ago. Before that, they occurred, on average, every 250,000 years. By that math, we are long overdue. And the most crucial clue, the one that has direct implications for us today, is found not in lava flows, but at the bottom of the ocean. In 2012, scientists analyzing a core of marine sediment from the floor of the Mediterranean Sea reconstructed the behavior of the field during the last full reversal. They found it wasn't a smooth transition. The field weakness and instability leading up to the final flip lasted for over 6,000 years. But within that period, the field occasionally attempted to recover, only to collapse again. It was a planetary battle, a tug-of-war between order and chaos that lasted for millennia. Has this happened before? And did life survive? The answer is written in stone. The most eloquent pages of this diary are volcanic rock. We have built a civilization of exquisite fragility atop a planet of immense and cyclical power. The archaeologic record is our warning. It tells us the storm is not a matter of if, but when. And the most pressing question now is not what happened hundreds of thousands of years ago, but whether the anomalies we are measuring today, the South Atlantic Anomaly, the rapid movement of the magnetic North Pole, are the first faint opening sentences of a new, terrifying chapter in that planetary diary. The survival of life through past events is our greatest cause for hope. It suggests that while the technological and societal disruption would be unprecedented, the biosphere itself is resilient. The reversal is a crisis for our civilization, not necessarily for our planet. The ancient rocks have told us the story of past reversals. Now, our most advanced technology is tasked with answering the most pressing question. Are we living through the opening chapters of the next one? The data from our global network of observatories and satellites is not giving us a simple yes or no. Instead, it is painting a portrait of a planet in the midst of profound magnetic upheaval, presenting us with clues that are both terrifying and deeply ambiguous. Simultaneously, the magnetic North Pole is behaving erratically. After centuries of a slow, predictable drift through the Canadian Arctic, it has broken into a sprint. Its velocity has increased from a stately 15 kilometers per year to a breakneck 55 kilometers per year, charting a direct and accelerating course toward Siberia. This shift is so pronounced that it forced an unprecedented early update to the World Magnetic Model in 2019. This model is the foundation for global navigation. Every smartphone map, every commercial airline's flight path, and every ship's navigation system relies on its accuracy. The planet's wandering pole is literally forcing us to recalibrate our sense of direction. So, what does this mean? Is this the prelude to a full-scale reversal? The scientific community is divided into two compelling camps, each interpreting the same data through a different lens. Camp 1. The Prelude. This group, which includes many paleomagnetists and geophysicists, sees a direct parallel between our current situation and the geologic fingerprints of past reversals. They argue that the South Atlantic Anomaly is a modern example of the kind of localized field collapse that precedes a flip. The rapid migration of the North Pole, they suggest, is a hallmark of the dipole field, the familiar two-pole structure, losing its dominance as other magnetic features bubble up from the turbulent core. Their computer models of the geodynamo show that this is exactly how a reversal begins, not with a bang, but with a slow, inexorable unraveling that can last for thousands of years. For them, the countdown began a long time ago. Camp 2, the false alarm. The other camp urges caution, proposing a different diagnosis, a geomagnetic excursion. An excursion is like a reversal that loses its nerve. The field weakens dramatically, the poles may wander wildly, and multiple magnetic poles can even appear, but then the field regains its composure and reverts to its original orientation. The geologic record shows these events are more common than full reversals. The Lachamp excursion, 41,000 years ago, saw the field drop to just 5% of its current strength for about 1,000 years before recovering. This group posits that the current instability could be a similar event, a near-death experience for the magnetic field, not its actual death. The terrifying truth is that we are living through a real-time scientific experiment. Our monitoring systems, like the European Space Agency's Swarm satellite trio, are the stethoscope on the Earth's chest, listening to the heartbeat of its core. They are gathering the data that will eventually provide a diagnosis, but the planet operates on a timescale that dwarfs human lifetimes. The prelude to a reversal could take 2,000 years. We have been closely watching for less than 200. The question is no longer if the field will change, but how severe and how prolonged that change will be. The countdown clock is ticking. We just don't know what number it started on, or what happens when it reaches zero. The Great Magnetic Flip is not an apocalypse. It is a generational challenge. It is a test of our species' ability to plan beyond a single lifetime, to cooperate on a global scale, and to adapt our technology to survive a fundamentally changed environment. Our mission is clear. We must harden our world. This means building smarter, more resilient power grids that can be shut down and restarted safely. It means designing satellites and spacecraft with much higher radiation tolerance. It means developing new materials and protocols to protect our electronic infrastructure. It is a monumental engineering problem, but not an insurmountable one. We must also learn to read the planet's vital signs. We need a global network of observatories, both on the ground and in space, dedicated solely to monitoring the magnetic field's rapid evolution. Data is our only map through this coming turbulence. Most importantly, the reversal teaches us a profound humility. We are not the masters of this planet. We are tenants, living in a house with foundations that occasionally shudder. Our survival depends not on conquering nature, but on understanding it, respecting its power, and adapting to its rhythms. The magnetic field has protected us since the dawn of life. Now, for the first time, the protector needs protecting. The shield requires stewards. The coming flip is not just a geological event. It is the moment our civilization grows up, looks up at the storm gathering in the silent sky, and decides to build a stronger roof.